Good morning, students.
Good morning, madam.
Okay, yesterday we have seen the block 3, some important questions. So one topic we have missed in the unit 2, it is about the linear differential equations. So that also you will get for the 10 marks question. We will see today that linear differential equation. And after that, we'll go to the fourth block. And last, we'll see the important questions. Okay, now you are able to see the board now. So in the introduction, I have told what is the linear differential equation. Oh, and what is the representation of that also you'll get for the 1 mark question, that is in the objective type. Unit 5. So linear differential equation. Okay. So this will be in the form of dy by dx plus p of x into y equals to q of x. Okay. So here p and q are the constant. P and q values, they may be constant or else they will be the functions of x. Means here x square y or something like that, we will get the terms in the, that means they will be variable and combination of the quotient of any constant term. So here dy by dx, this is the important one. This is you will get for the objective type of question also. What is the representation of the linear differential equation? So dy by dx plus p of x y equals to q of x. Okay. So for this, the procedure or the rule to solve the given linear differential equation is first you have to see whether the given question is in the form of this. That is here dy by dx is there. If your x variable is not there, means you may have here even constant term also. That is any real number. Okay. Here also you may have any constant term, but it should be in the form of this one. If it is not in this form, then you have to convert it in this form and you have to follow the procedure. Okay. First one is check whether it is in the form of linear differential equation or not. And second step is you have to see what is the p values and what are the q values. Okay. What is p value and what is q value. So after that, we'll take the integrating factor. Okay. IF is called as the integrating factor. Integrating factor is equals to e to the power of p dx. Okay. Whatever the p term here it is there, you have to substitute here and you have to do the integration of that one, and with the help of e, if any log term you are getting, means both will get cancelled and will get some value. Okay. So then the general solution is y into integrating factor is equals to integration of q into integrating factor into dx plus c. Okay. This is the general solution of the linear differential equation. First thing is check whether it is in this form. If it is not in this form, then convert it into this form. Then you see what are the p and q values. After taking the p and q values, and then you find the integrating factor. Why we use the integrating factor means we convert the linear differential equation into the exact differential equation. So for conversion of that one, we use the integrating factor. That is the definition of the integrating factor. So integrating factor, it is defined as e to the power of, remember even these terms also, e to the power of, that is integration of p dx, and last general solution is this one. Okay. So we'll see one example problem. So that may be anywhere in the MUQ or check your progress, or anywhere the problem will be there. You see from the textbook. I'm taking it as cos square x dy by dx plus y equals to tan x. Okay, this is the given differential equation. First thing is check whether it is in the form of like this dy by dx plus p of x of y equals to q of x. Okay. So here dy by dx is there, but for the quotient we have the cos square x. So cos square x should not be there. to convert it into linear differential equation. So for that purpose, you divide it by cos square x. Convert it into linear differential equation. Okay. So for that, divide by cos square x on both sides. So it is dy by dx plus y by cos square x equals to tan x by cos square x. Okay. So here 1 by cos square x we can take, that is the p value here. 1 by cos square x is from the trigonometric identity, it is secant square x. Okay. So dy by dx plus secant square x into y equals to tan x, means what you will write here, I am writing here only, it is sin x by cos x into, if you take it to the numerator, so 1 by cos square x. So it is sin x by cos cube x. Okay. So this is our q value. Now it is in the form of LD, that is linear differential equation. So here, now it is linear differential equation. So what is p value? P is equals to secant square x and q is equals to sin x by cos cube x. Okay. So what will be the integrating factor? Integrating factor is e to the power of integration of p dx. So e to the power of integration of secant square x into dx. So what is the integration of secant square x? So if you see the formulas, it is the integration of secant square x is the tan x. So e to the power of tan x. Okay. Now we find the general solution. So general solution is general solution is y into integrating factor. Our integrating factor is e to the power of tan x. It is equals to integration of q. You write formula here. Okay, in the examination, if you write the formula, they will think that you have done the whatever the problem it is there, it is by yourself. In the textbook, it will be direct answer will be given. No? Okay. So y into e to the power of tan x is equals to integration of q. Q is sin x by cos cube x into e to the power of tan x into dx plus c. Okay. So here no term is, we can't do direct integration for this one. Okay. Here it is in the form of u by v and also one more term is there. Okay. You have to take here tan x equals to t. Okay. Such that we can convert this whole into the variable t. Okay. So put tan x equals to t. So whenever we'll take anything substitution, compulsory you have to convert it into that variable differentiation. Okay. So tan x means tan x differentiation is secant square x. So it is secant square x into dx is equals to dt. So secant square x dx equals to dt. In the numerator, that is right hand side, you have sin x by cos cube x into e to the power of tan x. Here we can write one thing more. That is sin x by cos x means you will get tan x, no? So you can write it as, I am writing above. Here only conversion you take. So y it is equals to you are able to see dx equals to integration of q. Q is what is there? Sin x. Sin x means 1. You take here cos cube x is there, no? You write it as 1 by cos square x into Sin by x, no? Numerator one sin is there, denominator one cos is there. That is sin x by cos x into e to the power of tan x. Next step you can write that one because already we have taken here, no? That's why I have written. So it is integration of 1 by cos square x means it is secant square x, and sin x by cos x is tan x. Now into e to the power of tan x dx plus c. Okay. Now we have taken tan x equals to t, secant square x dx is equals to dt. So secant square x into dx term will become dt and tan x will become t. Okay. So when you substitute here, it is y into t is equals to e power x. We have e to the power of t, no? Tan x. So e to the power of t is equals to integration of secant square x dx is dt. Okay, right after that one, tan x, what we have taken t. So t into e to the power of t into dt plus c. Okay. Whenever you will not get the direct integration, so you have to take, you have to do the integration with the help of the substitution method. Okay. Now you do this part integration, that is, it is in the again UV form. So UV form means, if you want, you can write here the formula. It is integration by parts is there, no? That one. So f of g, that is if it is f and if it is g, t into integration of e power t dt minus integration of t differentiation. T differentiation is 1 into integration of e to the power of t here dt into dt plus c. Okay. You check the formula. T into e to the power of t. E to the power of integration is also e to the power of t minus integration of, this is already we have done. So 1 into again integration of e power t is e power t into dt plus c. So it is t into e to the power of t, again it is e power t plus c. So this e power t, if you take common, t minus 1 plus c. Now what is t? T is tan x. So you will get it as e to the power of tan x into tan x minus 1 plus c. Okay. So here also if you substitute, it is e to the power of tan x on the left hand side. E to the power of tan x. Since t is equals to tan x. Okay. Now tx, e to the power of tan x, e to the power of tan x on both sides. If you cancel out, what you will get? Y into is there. Okay. This e to the power of tan x, e to the power of tan x will be cancel out. Y is equals to tan x minus 1. Oh, that means you are taking this side. So for this, we have cancelled out e to the power of tan x. But for c constant term, it will be there, no? That is plus c into e to the power of minus tan x. It will come in the denominator. If we take it to the numerator, it will be c into e to the power of minus tan x. Okay. Or else you can write tan x minus 1 plus c also. Constant into any term, if you multiply, it will be that constant term only. Okay. So is the general solution of the given linear differential equation. Okay. So example problems are there in your textbook. In some cases, directly you can do, if simple q is there, then directly you can do the integration. Here we have somewhat complicated q value. So that's why we are converting it into in a simpler form such that we can substitute tan x equals to t such that it is converted into variable t. So we can do easily after substituting the t, whole whatever the terms are there, they will be converted into t. Then you can do the integration. Okay. So this is the method. So you have some example problems in your textbook and even some check your progress are also there and MEQ questions are also there. So try to solve from them. And one more is that generally we have the linear differential equation is dy by dx plus p of x into y equals to q of y. Okay. So that means this is linear in, we call it as linear in X. Okay. So instead of this, you may have some problems like this also. Dx by dy plus P of X equals to Q. Okay, only Q will be there. This is Q of X. Okay, means instead of dy by dx, if we have dx by dy plus P of X equals to, instead of here y, you will have the X. Okay, that means P of y of X equals to Q of y. You can write like this, P of y into, okay, this is linear in y. Okay. Here, if you have xx variables, we call it as linear in X. Only 2 or 3 problems are there for this type of linear differential equation. Just interchange of this one, dx by dy plus P of y into X equals to Q of y. That means linear in y. It is linear differential equation in variable y. Both will be same only. For this, integrating factor will be changing. That is, just instead of P of X, P of y will be there. That is, integrating factor is e to the power of P into dy. Okay. So integrating factor is e to the power of P of y into dy. Then write P of y also. And general solution is x into this one, integrating factor. There we got y into no. So this is linear in y. Therefore, we'll write a general solution is x into integrating factor. This is same. That is q into integrating factor plus c. Here also shall I write q into integrating factor into dy plus c. Here dx no. So here dy you will get. So these two are the different forms of the linear differential equation. First one is the linear in X and second one is the linear in Y. Even in your textbook you have this one. Okay, from there also you can write. And this is the one important one, linear differential equation. And next one is the Bernoulli's equation is there. So Bernoulli's questions you will get for the 10 marks questions. There is a 10th A. This is the second unit, no? So 10th A question will be from these two topics. Next one is Bernoulli's, and what is the representation of the Bernoulli's differential equation also you will get for the objective type of question. Okay, it is a compulsory question. Next one is Bernoulli's form. Okay, how it will be? Just it will be similar to linear differential equation only, but it is dy by dx plus P of y is equals to q into y to the power of n. You will have one more term, that is y to the power of n. It will be there. Okay, dy by dx plus P of x only, that is P of x into y, and Q of x into one more extra term is, that is y to the power of n will be there. So to solve such type of problems, you have to convert this Bernoulli's form of form of differential equation will be there. No, that you have to convert into linear differential equation. Then you have to find the solution. Okay, the procedure to convert Bernoulli's form to linear differential equation is form. That means you have to eliminate this y to the power of n. Okay, so to eliminate this one, first you have to divide with the whole whatever the equation is there with the help of y to the power of n. Okay, so after eliminating that, you have to convert it into linear differential equation. So the procedure is there here. So if you take this y to the power of n to this side, it will become y to the power of minus n dy by dx plus y to the power of minus n plus 1 into p. It is equals to q. So you are taking that side. So This what is y to the power of n is there. No? If you take this at numerator, means it will become minus n. And here already y is there. So minus n plus y power is 1. No? So minus 1 plus 1 into p is equals to q. Okay. So again, this term is extra no, for linear differential equation. To eliminate this linear differential equation, you have to take substitution for this one, y to the power of minus n plus 1. Okay. So put y to the power of minus n plus 1 equals to u. So you have to differentiate this one. Whenever you take this substitution, that compulsory you have to convert that into that variable. So this is minus n plus 1 into y to the power of minus n plus 1 minus 1. Okay. That is n into x to the power of n minus 1 into y differentiation is dy by dx equals to du by dx. Okay. So now this 1 and minus 1 will get cancelled. It is minus n plus 1 into y to the power of minus n dy by dx is equals to du by dx. See here, if this term is there here, we need this value. So y to the power of minus n dy by dx is equals to y to the power of minus n dy by dx is equals to, that is 1 by, this will come in the denominator now. So 1 by 1 minus n into du by dx. Okay. So we got this value. Minus 5 du by dx equals to this one. So now this substitute in this equation. If we take this as 1, so substitute this value in 1, you can write. So what it will come? 1 by 1 minus n into du by dx plus what is y to the power of n minus 1? It is u into p equals to q. Okay. Now this is the linear differential equation. So here 1 minus n should not be there, no? Linear differential equation means it is du by dx, du by dx plus, if it will come this side, 1 minus n into u, p is equals to q into 1 minus n. Okay. Now this is in the form of dy by dx plus p of x into, here u is the variable. Okay. Instead of y, we have the variable u, q into 1 minus n. Okay. This is linear differential equation, is linear in u. Okay. So now it is linear differential equation. Now same procedure. We have to take what is the integrating factor. Then we have to find the general solution. Okay. This is the procedure for this one. So we'll see from one problem on this. Okay, x y dash plus y equals to y square log x. That is x y dash plus y is equals to y square log x. Okay. Now you convert, that is in dy by dx, you convert this one. So it is x into dy by dx plus y is equals to y square log x. Here log x is q, it is y to the power of n, and this is whatever it is there, it is in the form of the Bernoulli's equation. Okay. Is in Bernoulli's form. So Bernoulli's form is, now we have to convert whatever y square is there, that y square, and also here x should not be there. Okay. So to cancel out both of them, you can divide whole equation by, divide by x into y square on both sides. What is the Bernoulli's form? Dy by dx plus p of x into y is equals to q of x into y to the power of n. Here also coefficient should not be there. So to cancel out this one, we are dividing with x y square. So x and y square means x's will get cancelled. Whatever if y square is there, that will come to the numerator and it will become minus 2 dy by dx plus here y by xy square is equals to y square will get cancelled log x. Okay, this y, whatever here power it is there, or else you take this denominator to numerator, it will be minus 2. So it is positive 1 is there, it is negative minus 2 is there. So you will get y to the power of minus 1. So y to the power of minus 2 dy by dx plus 1 by x into y to the power of minus 1 is equals to log x. Okay, next step, what is that? You have to take y to the power of, now you take this as equation 1. Okay, put y to the power of minus 1 equals to u implies minus 1 into y to the power of minus 2. When you do the differentiation of this one, okay, into dy by dx is equals to du by dx in 1. Okay. Only this part, no. Again, you can write this as y to the power of minus 2 dy by dx is equals to, you take this minus to this side, okay, right hand side. So it is equals to minus du by dx. If you take here also, here it is a minus is there. So du by dx means here minus du by dx. Anywhere it will be same only, okay. So in 1, okay. So it will be minus du by dx plus 1 by x into y to the power of minus 1 is u is equals to log x. Okay. So again you take the minus term inside. So you will get it as du by dx minus 1 by x into u is equals to minus log x. Okay. Now this is in the form of linear differential equation. To convert Bernoulli's form to linear differential equation, we have to follow this procedure. And one more term we have missed. What is that? Here x will come. No? So x y square will get cancelled, but x will be there here. So by x, and here also by x, and also by x. Okay. So now is linear in u. Okay. Here the variable is u here. So now what we have to take? So what is p value? P is equals to minus 1 by x, because here plus sign will be there in linear differential equation. Okay. So it is minus 1 by x, and q is equals to minus log x by x. Okay. So what is the integrating factor now? Integrating factor is e to the power of integrating factor is equals to e to the power of, directly I am writing, I am not writing the formula, e to the power of minus 1 by x into dx. So it is equals to, what is 1 by x? Integration 1 by x integration is log x. So e to the power of minus log x you will get. So we can write it as e to the power of log of x to the power of minus 1. Okay, this negative if it will go there. E and log both will get cancelled. Both are minus 1, so both will get cancelled. So it is x to the power of minus 1. It is 1 by x. Okay, so integrating factor is 1 by x. So now general solution is here it is linear in u. The variable is here u. So u into integrating factor. Integrating factor is 1 by x equals to integration of what is q? Q is minus, I am taking outside, log x by x into 1 by x. Integrating factor, this whole dx plus c. Okay. So now this left hand side, it is simple way only. You can keep like that only. But here log x into whatever it is there, it is in the form of uv. So to convert that one, that is integration by parts, we have to do the integration. Okay. log x by x, we can write this as it is equals to minus integration of, this is numerator log x into x is x square. If you take it to the numerator, it will become x to the power of minus 2 into dx plus c. Okay. Now, integration of log x will be not there. Okay. Only 1 by x is log x. Now, this is again in the form of f dot g, that is integration by parts. Now, apply the integration by parts formula. First, f of x you take outside, that is minus term you take common, log of x into integration of x to the power of minus 2 into dx minus integration of f of x, that is log x. Directly I am writing the differentiation here. If you have any doubt, you can write like d by dx of log x into d by dx into log x into integration of x to the power of minus 2 into dx, again whole dx plus c. Okay. So this is the f dot g integration of f dot g. Already I have told in the introduction. So collect from their formula. Okay. So minus of log x and integration of x to the power of minus 2 means it is in the form of x to the power of m. Integration of x to the power of n is x to the power of n plus 1 by n plus 1. So here into x to the power of minus 2 plus 1 by minus 2 plus 1 minus differentiation of log x is 1 by x. And this is again minus 2 plus 1 by minus 2 plus 1 into again one more differentiation will be there. No? One more integration. Okay. So minus 2 plus 1 means x to the power of minus 1. Here we will get in the denominator minus. So it is equals to minus of log x into x to the power of minus 1 means it will be here minus x. Okay. X to the power of minus 1 in the denominator minus. So minus, if you take that to denominator, it will be x. Minus integration of, here again minus 1, here minus 1. So minus you take outside, that minus will become here plus. So 1 by again this is x square. Okay. Into dx plus c. So here it is minus of log x by minus x plus again x to the power of minus 2 dx plus c. So it is minus of log x by minus x plus again x to the power of minus 2 means just now we have written now, that is x to the power of minus 2 plus 1 by minus 2 plus 1 plus c. So it is if you multiply with minus will get cancelled. So log x by x and this again minus you will get x to the power of minus 1 in the denominator minus both will become plus. So 1 by x plus c. Okay. Log x by x plus 1 by x plus c. Here u into 1 by x. Okay. If we take all x common, okay, in the denominators, this x and this x both will get cancelled. Then again you can write the general solution as u equals to that is u by x is equals to log x plus 1 plus cx. Okay. If you do the LCM here, cx by x. So this x will get cancelled. U is equals to log x plus cx plus 1. Okay. Now again, what is u? Starting what we have substituted u is equals to y to the power of minus 1. Okay. That is u is equals to 1 by y. Now substitute here. U is 1 by y is equals to log x plus cx plus 1. If you do the cross multiplication, you will get 1 is equals to y of log x plus cx plus 1. So this is the solution. Okay. The required solution. compulsory you have to convert into again its variable, whatever the problem is given. So this is the Bernoulli's method, how to find the solution for the given problem. So this is also important. So example problems you have in your textbook. So try to practice them. So one 10A question you will get from linear or Bernoulli's equation, and second one we are not touching the 10B, that is a 10B 10 marks question, exact differential equation. Okay. So actually it will take whole whatever one class is there, almost one class also it will not be sufficient. 2 classes we need for the exact differential equation. So in that 4 different exact differential equation will be there. That with the help of that only you can solve the problem. So 10A problem I have told. So 10B, if you have time, practice all the procedure is there in your textbook. From there you start. Okay. And only one thing you remember, that is m dx plus n dy is equals to 0 will be the form of the exact differential equation. So whenever differential equation is in the form of m dx plus n dy equals to 0, we will find dou m by dou y. And also here, by seeing the question, you can understand what is m value and what are the n values. So if you take them and if you do the partial differentiation of them, so if dou m by dou y and dou n by dou x, both the values if we get the same, then whatever this differential equation is there, that we call it as exact differential equation. Okay. So this is called as necessary and sufficient condition for any differential equation to become exact. So one objective type of question, you will get this one. And you should know what is exact differential equation. When the partial differentiation of m and n with respect to y and x, you get the same values, then it is called as exact differential equation. Okay. So on this only you will have the problems. Okay. Due to less time, we are unable to going into this exercise 9. Okay. So that is exercise 6. Yesterday up till exercise 9 we have seen. So today just I will tell one problem on, that is a 12th unit. From the 12th unit you will get the 12B question. So one 5 marks question you will get, that is a partial differential equation, and next one is Lagrange's method will be there for finding the problem. These 2 topics are important. That is a formation of partial differential equation is the 5 marks question, and this Lagrange's method is the 10 marks question. That is here directly I am going to unit 12. Formation of partial differential equation. Partial differential equation. Okay. So for that you have the procedure is there. And in that we'll take some terms will be there. The terms are, we'll write the dou z by dou x as dou z by dou x as P and dou z by dou y as Q. That is small q or capital Q, anything. Okay. So these 2 are important. Dou z by dou x will take it as P and dou z by dou y equals to Q. Okay. So fourth unit 2 we have seen the unit 4 that in block 2 unit 4 we have seen the formation of differential equations. Almost somewhat it will be like that only, formation of partial differential equation. Okay. So one example problem we see, by that you can understand this one. That is z equals to f of x square minus y square is there. So question will be form the partial differential equation from the given equation. Okay. So z equals to f of x square minus y square. Okay. So this you take it as 1. So differentiate 1 partially. Okay. Already I have told what is the difference between the partial differential equation and differential equation. In first semester also you have. Okay. So with respect to of what variable you are doing the differentiation, that variable only you have to do the differentiation. Okay. So that means another variable will be the constant one. So with respect to of x we are doing means only x square we have to do. With respect to of y means only y square you have to do the differentiation. Okay. Differentiate 1 partially with respect to x and again with respect to y on both sides. Okay. So at a time I am writing that one. So now this will be dou z by dou x if you are doing with x. So this you have a whole of f of x form it is there. So you can't split this one. Directly you do the differentiation of the function. So it will be f dash of x square minus y square into. But we are doing with respect of x. So from here you take the differentiation of the variable only x square. This will be 0. This is only you have to do the differentiation. So it is into 2x. Okay. Next, when you do with the help of y, dou z by dou y is equals to same f dash of x square minus y square. This is 0. So what is y square? Y square is minus 2y. So minus 2y. Okay. So I have told dou z by dou x is p here and dou z by dou y is q here. Okay. So we can take here both the terms as p and q. Now p divided by 2x we can write now from here. From 2 p by 2x is equals to f dash of x square minus y square, and from 3 q by minus 2y is equals to f dash of x square minus y square. Okay. From these two equations we got p by 2x equals to this one. Both are same now. So you can equate these two equations. You can take this as 4 and 5. Okay. From 4 and 5 equations we have, that is p by 2x is equals to q by minus 2y. Okay. So 2 will get cancelled. Implies what you will get? This is minus yp. This is also minus xq, no? Minus xq equals to 0. So if we take out minus common, it will be yp plus xq is equals to 0. Okay, like this you have to find the equation of the, that is a partial differential equation. So it is small q you take, in the test tube it is small q it is there. Okay. So like this, you have to convert whatever this we are getting, it is called as a partial differential equation. So converting the given equation into the partial differential equation, the procedure is this one. That is partially we have to differentiate the given function here. Okay. So if anywhere you are getting dou z by dou x or dou z by dou y, then you write them as p and q and then you convert this one. Okay. So I have told the procedure how to find this one. You have many examples and every problems are there. Okay, you see from there. Already it is 11:20. So last method is I am telling only Lagrange's method. Within the 5 minutes I will tell. After that we'll take the important questions. So almost each and every block we have seen the 10 marks and the 5 marks questions. So Lagrange's method means so the given problem will be in the form of like this. P, this is the capital P and this is the small p, plus q and small q equals to r. Okay. So whenever it is in this form, it is called as the given problem is in the Lagrange's method. Okay. Now we have to convert this into its subsidiary equations. We call it subsidiary equations. So subsidiary equation is dx by t is equals to dy by q is equals to dz by r. So given question you have to convert it to this form, and I hope so unit 7 or unit 8 we have to find the by taking any two terms, we have find the solution. No, same that procedure you have to follow here. Okay, but the given problem will be like this. If it is in this form, it is called as Lagrange's method. Then you have to convert that into the subsidiary equations. Then same procedure. You have to take any from these three ratios, any two ratios means you will get one solution. If you take another two ratios, you will get one more solution. So this is the procedure of Lagrange's method. Okay. We'll see one example problem, that is you have p root x plus q root y is equals to root z. Okay, this is p into p into p plus q into q is equals to r. Okay, so it is in the Lagrange's method. You can write is in, from here only I am writing solution, is in Lagrange's method. So the subsidiary equations are okay, you will write dx by t. So dx by, that is this root x, is equals to dy by q root y equals to dz by root z. Okay. Now you have to take any two ratios, either these two or 1 and 3. Okay. So take first two ratios. So that means, and integrate directly. I am writing here and integrate. So what it will be integration here? No cancellation is there. Directly you can do 1 by root x into dx is equals to integration of 1 by root y into dy. So 1 by root x means x to the power of minus 1. This is integration of x to the power of minus 1 by 2 dx is equal to integration of y to the power of minus 1 plus c1 here. Okay, for first solution we have the c1. So directly I am writing the answer here. You know now x to the power of n form means n plus x to the power of n plus 1 by n plus 1. So minus 1 by 2 plus 1 by minus 1 by 2 plus 1. So minus 1 x to the power of again minus 1 you will get. So you will get it as root x and this as root y plus c1. You do that simplification. Okay. It is root x minus root y is equals to c1. This is one solution from the first terms. Now if we take the first and last. Take, or you can take second and third also, anything. Okay. Take first and last ratios and on integrating we get, what is the first one? That is 1 by same root x dx is equals to 1 by root z dz plus c2. Okay. So this also again you will get root x minus root z is equals to c2. So this you can take 3 and this you can take 2. Okay, equations. So the general solution is pi of root x minus root y comma root x minus root z equals to 0. Or we can write it as root x minus root y is equals to, one more form will be there, equals to pi of this one, root x minus root z. Like this or like this, anything you, if you remember the above one, you write that solution. If you remember the down, you can write that one. Okay. Like this, you have to find the Lagrange's method. Actually, some problems they will be in the form of like this, direct integration. If you do, you can solve the problem. And one more method will be there, that is by multiplying with the multipliers. So multiplies will be there. If you multiply them, then only you can solve the problems. Okay, that method you see from the textbook. Example problems are there. If you take one more, means it is very lengthy problems are there. Okay. So if we have the test books, open the test books. One method I have told for the Lagrange's. Next method you see from the test book. So all of you are having the test books, sir. Just you message it.
Yes, yes.
You're having test books, no? So try to open them and take any one pen or pencil, anything, okay? Page number 4. All the derivatives and integration also formulas are there, no? These are important for the objective type of questions. Next, 9th page number 9, 1.3.9. Here also we have the formulas are there. And page number 9 only, above theorem you have no integration of f dash of x by f of x into dx. That formula also, okay. Next, page number 10. So integration of, if you see the table in the page number 4, you are not having some formulas for integration of tan x or cot x or secant x, okay. That you have the solutions here. If you write all the formulas in any of your textbook, try to write the integration of tan x formula, cot x and secant x from here, page number 10 and 11. Okay. These are even useful for solving the problems also. Page number 10, 11 formulas are there. See those. And page number 12, 1.3.14. 1.3.14. Next, integration using trigonometric identities. I have told problems on this. You see there. Page number 14. These are all formulas. Just if you know the answer, it's enough. And any one problem you will get for the 5 marks also. Page number 14. Integration of 1 by root of a square minus x square are there, no? So in page number 16 also you have them. Even 17 also. This, the formulas are important. Next, page number 19. 1.3.28. This is the 5 marks problem. Next to 29 also, next page, 20 page number, 1.3.29. Next page number 25, all trigonometric, whatever the functions are there, integration of inverse trigonometric functions. These are, you will get, see from the unit 1, all the formulas almost you will get for the math the following, or there is a multiple choice questions, or even in the fill in the blank. So they will ask the formulas, okay. So from the unit 1, try to write in your notebook all the formulas, whatever the inverse are there, and even trigonometric formulas are there. Try to write them and by heart them, okay. 25 page number 26 also you have. Next to 29 page number 1.5.1. Page number 32. Here reduction formula is there, no? Reduction formula for integration of sine to the power of n dx. This you will get for the objective type of question. Formulas also they will ask, okay. And integration of sine to the power of 4x dx is there, no? Okay, next second unit. 45 page number in the down you have, no? integration of a to b f of x dx equals to minus integration of b to a f of x dx. These formulas. Just you write the only whatever the heading is there, no need of the proof. Just above one, if you write it's enough. This is also objective type of one. Next 49 page number 2.3.6. This is the 5 marks question and also 7 also 2.3.6 and 7. Next 50 page number 2.3.10. This is also 5 marks question. 51 page number, check your progress, second one. Check your progress, second one. Next 52 page number, above theorem is there, no 2.4.1. This is the objective type of question, okay. 0 to pi by 2 sine to the power of n dx, it is there, no. Next to 54 page number 2.4.4. 56 page number 2.4.8. This is the 10 marks problem. Okay, proof is there, solution is there for this one, no? 2.4.8. Next 57 page number, check your progress. You have fifth question above it is there, no? This is also 10 marks problem. I have told this problem and even I have told the formula also. So just in the formula you substitute the values, then you will get the answer. Okay. This is a very simple one. Easily you can score 10 marks here. And next 58 page number. That is the first sixth bit is there, no MEQ questions. MEQ questions. First one. Sixth bit in the first one. It is also 10 marks question. Now we'll go to the application of integration. 63 page number 3.2.2. It is finding the area by the ellipse. Next is 64. 3.2.4, 3.2.5. That is sin x and cos x. And page number 67, 3.3.3. These are all 10 marks. So compulsory from the unit 3, you will get 10 marks questions only. 3.3.3. Finding the area enclosed between the line y equals to x and the curve. Okay, now we'll go to the unit 4, 79 page number. So for order and degree, check your progress. 1 is there now. And here example also, page number 78, example problem, and check your progress 1. These are 1 mark questions, objective type. And even backside you have second problem also. 80 page number. 81 page number, 4.4.1. Form the differential equation by eliminating arbitrary constants. This is the 5 marks question. Next, 82 page number 4.4.3. 83, check your progress 3 and 4. 83, check your progress 3 and 4. Next, 84 page number. Model examination questions are there, no? Third one and fifth one. Fifth one I have told for you problem. Third one and fifth one. And fifth unit. And that is page number 87. Page number 87, 5.2.2. This is the 5 marks question. And page number 89. Check your progress, second one. This problem also I have told. Okay. Check your progress 2. Next, 92 page number. Check your progress is there, no? third problem and fourth problem. Third and fourth, these are 5 marks questions. (95) page number. So that is 5th question and 6th question. These are the non-homogeneous, no? So it is a 10 marks one. And linear equations we have 5.5. What is the form of the linear equation? It is a 1 mark question. Okay. dy by dx plus p of x of y equals to. And even what is the integrating factor also you may get for the objective type. Next, 98 page number. This 8th question I have told, check your progress. Cos square x dy by dx plus y equals to. Next, Bernoulli's equation is important. What is the representation of the Bernoulli's equation? 1 mark question you will get. Next, 99 page number 5.6.1. This is 10 marks. 100 page number 100 5.6.3. This is also 10 marks. Next, 101 is, I have told this one, y square log x. This no, okay. This is also 10 marks only. And 104 page number, MEQ questions are there, no, in the 5th bit. So these are also Bernoulli's only, okay. So second one, y dash equals to x square y cube minus xy. And 6th question. So exact differential equation, I am telling the important questions. So if you have any time for the, means you have more time for your examinations, so you can practice them. First one is 109 page number 6.2.4. Theorem is there, no? So theorem they will not ask, just it is 1 mark question. Objective type of question will be there. What is the necessary and sufficient condition for the differential equation mdx plus ndy equals to 0 to be exact is? You may get in the multiple choice or any match the following, even in the fill in the blanks also you will get this one, okay? So if it is an exact differential equation, you will have the general solution. It is in the page number 111. This also means 6.3 is there, no, last one. U plus integration of pi of y into dy equals to c. So this is the solution of the exact differential equation. This also will get as the objective type of question. So 1 5 marks problem also you will get on the exact differential equation. (119) page number and even 118 page number also. Above formulas are there, no? 1 to 7. These also will get in the objective type of questions. 1 to 7. And 119 page number 6.5.3. These also objective type of questions. Now 120 page number 6.5.5. 6.5.5. It is 10 marks question. And 6.5.6. This is also 10 marks question. Next one, 124 page number. MEQ questions are there, no, in the third bit, third one, and 8th one. Third bit, third one, and 8th one. So these two are also 10 marks questions. Next, now we are going to the block 3. So block 3, we get only 5 marks questions here. (133) page number. 133 7.4.2. This is the 5 marks question. 7.4.3. Next page, 134. Check your progress 5. And 135 page number, Clauret's differential equation is there, no? What is the representation of the Clauret's differential equation also you'll get for the objective type of question. Okay. Y equals to xp plus pi of p. Just you remember that it's enough. Okay. If any, on this also problems, they will ask, if any question is direct on this one, just you substitute p value as c. That is the solution of that one. So no need of doing all the procedure of the solution. If directly the given question is in the form of y equals to xp plus y of p, then the solution of that is p. Instead of p, you have to write c. Okay. We have the examples also here. Page number 137. Check your progress 7th and 8th. Here directly they are in the form. So if you write instead of p, c, then it is only the solution. Okay. Objective type also you will get 5 marks question also you will get this one. So those are the 5 marks question. Next, orthogonal trajectories is the 10 marks question. Orthogonal trajectories. I have told on the problems. One 147 page number 7.8.9. 7.8.9. And again 155 page number. 155 page number, 7th bit it is. Okay. So in that first one, third one, fourth one, and fifth one. First, third, fourth, fifth. These all are the 10 marks questions, orthogonal trajectories. In that fourth question, I have told. Second one also, I have told at the introduction time. Okay. Next, unit 8. So, unit 8, check your progress, 163 page number, second one. (164) page number, 8.4.3. This is the 10 marks question. 8.4.3. And 168 page number, check your progress. Fourth question. So this is also 10 marks one. So if you practice these problems, it's enough for your examination. 182 page number, MEQ questions are there, no? In that fifth question, fourth and fifth. These all are the 10 marks question. Even I am telling you which
number, ma'am.
What, ma?
Page number, new question.
Page number 182. Fourth question.
Ma'am, first bit or second bit?
Second bit.
Fourth and fifth, huh?
Fourth and these are the 10 marks questions.
Fourth and
Page, that is unit 9, next one. In unit only 5 marks, but you will get the objective type. Okay. 192 page number 9.457 76 456, and even you see 4 check progress 1 3 also you see is in the don't disturb.
9th యూనిట్ మళ్ళీ చెప్పండి మేడం.
192 పేజ్ నంబర్ మధ్యలో మీకు 192 పేజ్ 6.4 fourth, sixth and check the progress లో 1 2 3 నుండే ఆబ్జెక్టివ్ టైప్ కూడా వస్తాయి.
Ma'am, can you repeat? Ma'am, can you repeat what you have said?
సో మాట్లాడుతున్న మధ్యలో జస్ట్ ఒక 5 minutes వెయిట్. 192 per 6.4 1 2 3 objective type, that answer you have to write 5 marks, you have to write the solution. Okay, 199 page number. Next to 200 also. Check your progress 6th and 7th.
Ma'am, 199 page number, which question did you say?
199 9.5.1 2 and 2 6 7 8. Check your progress. This method is easy one, so even MEQ questions also try to practice by yourself. Okay, so in the blanks you get questions, and also type of, that is multiple choice also, you will get the questions from this unit. We are going to the block 4 209 page number 10.1 10.3. These two are also 5.
Two not four.
Madam, can you repeat again?
209.
Your voice is breaking.
209 questions. 211 10.3.4 10.3.5 212.3.6. These all are 5 questions, and even objective type also you will get. Page number 13. Third and fourth question. Check your progress. 218 third and fourth question. 221 page number 10.4.3. Okay. Unit is important one. You will get the questions here. 230 page number. There is a particular equation. 234 page number 11.41. It is question. 235 page number 11.4.2. It is also 10 marks. 36. 236 11.4.4 and 230 progress fourth one. Check your progress. Okay, now last unit, that is unit 2. .252 page number. This is the 5 marks differential equation. 252 12.2.1. 255 12.2.4. 257 257 third and fourth. Third and 260 page number 12.4.1, 12.4. These are the 10 marks questions.
Ma'am, repeat
Sorry,
again.
ma'am, your voice is breaking.
262, 12.4.2, 260. కొంచెం సేపు మాట్లాడి 12.4.1, 12.4.2, 12.4.4. Page number 263. Next is 265 page number. Third bit is there no questions. I have told just now. This is also 10 marks question.
All questions.
266 page number. Third and fourth. Third and fourth.
260.
266 page number. Third and fourth question. Above is there no. This is also Lagrange's method only.
Okay.
This is 10 marks question. Okay. So, my class, what are the topics I have told there? So, from that, try to solve all the problems, whatever in the important questions, and practice the problems. Okay.
Okay, thank you, ma'am.
క్లాస్ అయిపోయిందా?